In the following video, we'll walk through the demonstration featured in the blog post, Stream Processing with Apache Spark, Kafka, Avro, and Apicurio Registry on AWS using Amazon MSK and Amazon EMR. The post is a follow-up to the previous post, getting started with Spark structured streaming and Kafka on AWS using Amazon MSK and Amazon EMR. First, we'll examine the architecture used in the demonstration. Next, we'll look at the dataset used for the demonstration. Then, I'll share a link to the source code used in the demonstration, which is all open source on GitHub. Lastly, we'll spend the majority of our time walking through the demonstration. Architecture. In the demonstration, the raw code is loaded into Amazon S3, which is our data lake. We run a series of PySpark scripts using Amazon EMR. The scripts, which I will detail in a moment, demonstrate Spark structured streaming. The Spark structured streaming scripts will consume messages from Apache Kafka hosted on Amazon MSK. The messages are stored in Apache Avro format on Amazon MSK. The schemas for the Avro format messages are stored in Apicurio Registry. Apicurio Registry is running in a container hosted on Kubernetes using Amazon EKS. In addition to Apicurio Registry on EKS, we are also running a container to execute the Kafka API commands against our Amazon MSK Kafka cluster, primarily to manage the Kafka topics associated with the demonstration. Amazon EMR, MSK, and EKS are all running in the same AWS account within 3 separate VPCs. The VPCs have been connected using VPC peering. Security groups with the proper ingress rules have been established to ensure secure connectivity between the services. There are 4 scripts which we examine as part of the demonstration. The first script, a Python script, creates a series of schemas, aka artifacts, in Apicurio Registry. These schemas represent the Kafka message values and keys we will consume with Spark structured streaming scripts. The second PySpark script simulates an event stream. The script sends several hundred messages representing real-time sales transactions from a file loaded into Amazon S3 to a Kafka topic at a regular interval. The third PySpark script uses Spark structured streaming to consume the sales transaction messages from the Kafka topic. The script enriches the stream of messages from Kafka by joining the data in real time to a static list of sales regions. The PySpark script then performs streaming aggregation of the sales amounts and order quantities over a sliding event window by sales region. The script writes the results to a second Kafka topic every 2 minutes. The fourth and final PySpark script consumes messages from the second topic as a batch. The script then summarizes the final results by sales region. Dataset. The dataset used in the demonstration comes from the Pagilla database. The Pagilla database is an example database provided by PostgreSQL. The database contains data which mocks a global, online video rental company. The main data set in the demonstration is a simple list of sales transactions. They contain the payment ID, customer ID, transaction amount, payment date, and the city, district, and country in which the transaction took place. The second data set is a list of countries and their associated sales regions. As part of the demonstration, these 2 data sets are joined in real time. Source code. All of the source code for this demonstration is open sourced and available on GitHub at github.com/Gary Stafford /Kafka-connect-msk-eks. Demonstration. Next, I will walk through the demonstration as detailed in the blog post. To prepare for the demonstration, I've uploaded the 4 scripts, 1 Python script and 3 PySpark scripts, and the 2 CSV format data files to an Amazon S3 bucket as shown on the screen. I've also created 2 Amazon EMR clusters arbitrarily called small and large. We will launch our Spark jobs, aka EMR steps, from these 2 clusters. We will be streaming messages to Kafka from the first cluster and consuming messages from the second EMR cluster. We could also run both Spark jobs concurrently from the same EMR cluster. However, using 2 clusters seems simpler for the demonstration. Lastly, I have a fresh copy of Apicurio Registry running with no artifacts. The first script, a Python script, 10_create_schemas.py, creates artifacts in Apicurio Registry. These schemas represent the Kafka message key and values for 2 topics, as well as the schemas for the 2 CSV format sales and sales regions data files, for a total of 6 schemas. Apicurio Registry supports several common artifact types, including Avro, GraphQL, JSON schema, Apache Kafka Connect schema, Google Protobuf, WSDL, and XML schema definitions. We will use a registry to store the Avro schemas for our topics, as well as the schemas for our CSV format data files. Although Apicurio Registry does not support CSV schema, for use with PySpark, we can store the schemas for the CSV format sales and sales regions data in the registry as JSON format Avro schemas. We can then retrieve those JSON format Avro schemas from the registry, convert it into a PySpark struct type, and associate it to the data frame used to persist the data from the CSV files. Using the registry allows us to avoid hard-coding the schemas as a struct type in the PySpark script in advance. I will now submit the script as an EMR step to our first EMR cluster. Once the script completes, we should have 6 schemas in Apicurio Registry. I have all the commands created ahead of time to save some time, so I'll go ahead and run those. And I'll run the first step, and we're going to submit this to the large cluster. And this will run 10_create schemas.py and create the 6 schemas. So we've submitted that step to our EMR cluster. If I flip back to the console, go to EMR clusters, and we'll go into our large cluster. We should see one step submitted. If I go to the steps tab, in fact, we see the first step running. We'll let that finish, and then we'll take a look at the results. If I flip back to Apicurio Registry, we should now see our series of 6 schemas. And we do. So we can see we have 2 keys and 2 values along with regions and sales. The keys and values represent the 2 Kafka topics. The regions and sales represent the 2 CSV format files. If I look at the sales schema or artifact, we can view the contents. They're in JSON format, so they're easy to view. These are the schemas that we will apply to our Kafka topics, the messages that we read from Kafka, and the sales data, which is in CSV format as we ingest it using PySpark and write that back to Kafka. Looks like everything works, so we'll move on to our second and third scripts. The PySpark script 11_incremental_sales_avro.py reads approximately 2,000 sales records into a PySpark SQL data frame from a CSV file located in S3. The script then writes those messages to a Kafka topic, pagilla.sales.avro.demo, at a regular interval of about 1 message per second. The third script, a PySpark script, 12_streaming_enrich_avro.py uses Spark structured streaming to consume the sales transaction messages from the Kafka topic. The script enriches the stream of messages from the Kafka topic by joining the sales data in real time to a static list of sales regions. The PySpark script then performs streaming aggregations of the sales data, both the sales amount and order quantity, over a sliding event time window by sales region. The script then writes those results to a second Kafka topic every 2 minutes. I will start the third script, and once it's running, start the second script. The second script will start producing messages to the Kafka topic, and the third script, using Spark structured streaming to consume the messages, will consume the messages, enrich the sales data, and perform streaming aggregations. Finally, it will write the results out in micro batches every 2 minutes to a second Kafka topic, pagilla.sales.summary.avro.demo. I'm going to go ahead now and submit both jobs to Amazon EMR. Again, I'm going to submit the third job, 12_streaming_enrich_avro.py, to one cluster. Once that script is up and running and starting to consume messages, I'll start the second script, 11_incremental_sales_avro.py. That script, the second script, will start producing messages, which the third script will start picking up using Spark structured streaming. I have all the commands already set to go, so I'll just pick those up. I'm currently logged into the large EMR cluster. I'm going to submit the step to start our third script running. So you can see that I've submitted the command and the script is starting. This PySpark job is committed to the EMR cluster. We'll let that get running and make sure there's no errors and it starts up properly. You can see that the script is starting successfully. We can see that the script was able to read in the schemas from Apicurio Registry. We also saw that it successfully read in the sales region CSV format data from S3. It looks like it's now up and running. Give it another minute, and I'm going to go ahead and start the other script in our second EMR cluster. Let me log into the second cluster. So I'm now logged into the second cluster. Let me clear that. And I'm going to submit the command to get our second script running. So again, this script is reading in about 2,000 sales transactions from a CSV format file from Amazon S3. And it's going to write those sales transactions on a regular interval over the course of about 30 minutes to the first Kafka topic. The script which we started first, the third script, will be consuming those messages as it finds them in Kafka. So you can see right now, the third script is running what's referred to as micro batches, batch ID 0. We have batch ID 1. As this continues every 2 minutes, we should see a new batch. Once this script starts finding messages the second script has written to Kafka, it will start aggregating those, enriching that information with our sales data, and outputting micro batches with sales aggregated by sales amount by region, and writing those to the second Kafka topic. So we're going to let this run in the background. I'm going to stop the video. Again, this takes about 30 minutes to run. And once this is done, we'll look at the results. What we would expect to see in the log output from the third script is a series of batches, which show an aggregation of the sales with an enrichment using the sales region. So we see our second script is still running successfully. And we can see at a regular cadence, each one of those sets of log entries are new messages being written to the Kafka topic. So if I were going to the Kafka topic right now, which I'll do in a minute, we would expect to see a series of messages being written at a regular interval to the Kafka topic. We should also start seeing batches of sales being read by the third script and aggregated, enriched with the sales region, and written back to the second Kafka topic. So at this point, I would expect both Kafka topics have been created and there is entries for both. So we can see one of our first micro batches that contain messages. If I look up here, we have batch ID 1. It contains 104 messages. So it's processing messages. The starting offset was 0. The ending offset in the pagilla.sales.avro.demo Kafka topic was 104. So it's processed 104 messages so far, and it's output 20 of those to the second Kafka topic. Again, since we have a sliding window and we have overlap, it will consume a particular number of messages. It will then, within that sliding window, within the time frame that's been defined in the script, aggregate those sales and then write those back out to the second topic. And we'll take a look at the results once this is done. So again, I'm going to let this run for a while. This could create a series of micro batches. This will continue to run. This job will also continue to run until it processes all of its 2,000 messages. The third script will continue to run since it's a Spark structured streaming job until I choose to stop it. So we can see we have another batch now. We have a batch ID of 2. So we went from an offset in the pagilla.sales.avro.demo Kafka topic from message 104 to message 228 for a total of 124 rows of data, of which 22 rows were output. So again, we're using a sliding event time window. This script is reading messages which are being streamed in real time to our first Kafka topic. It's aggregating the sales amount and order totals. It's enriching that with the sales region, and it's writing that back to a second Kafka topic. Again, we see that our second script is still running, so our incremental sales are still running. Those sales transactions, 2,000 sales transactions, are being written to our first Kafka topic at about 1 message per second. So we've slowed down the write time in order to simulate an event stream. This is trying to simulate actual sales data coming in from different point of sales locations and being collected and then written into Kafka topic for analysis. Again, the third script is writing micro batches back to the second Kafka topic in 2-minute increments. It's using a 10-minute window with a 5-minute overlap. So it's taking sales every 10 minutes worth of sales, aggregating those sales, looking at the total sales by region and the total quantity by region, and then writing those totals back to the second Kafka topic. So we can see we have another batch. It's been another 2 minutes. This batch, batch ID 3, went from an offset of 228, or in the pagilla.sales.avro.demo.kafka topic, message 228 to an ending offset of message 355 for a total of 127 input rows. This will continue again every 2 minutes. It's about 30 minutes worth of sales data, so I would expect at least 15 to 20 micro batches of Spark structured streaming data will be aggregated, which will contain sales information, and those will be written out to the second Kafka topic, which will be able to then read back off that second Kafka topic in batch format and take a look at those sales aggregations again over 10-minute windows. So I've paused the video for a few moments, and we are now currently up to batch 10. So we are at record 1236 out of 2000. So we're about 2/3 of the way through our records. I've opened a third terminal and I've logged into my Kafka Connect container. So I'm running Kafka Connect, the Kafka APIs, Apicurio Registry, Cruise Control, a few other Kafka applications in Amazon EKS or Managed Kubernetes Service. So I've logged into a container, and from this container, I have access to the Kafka APIs. I've gone ahead and listed out the different topics that are associated with my cluster. I've cleaned that up a little bit for clarity. So you can see here, we're interested in these last two topics. So if you remember the topic names, we're writing the initial sales data to the first topic. We are consuming that, enriching it, aggregating it, and writing that information back out to a second topic. And you'll see here that the two topics were created. So pagilla.sales.avro.demo and pagilla.sales.summary.avro.demo. So those are our two topics. We can also look at the contents of those topics. So let me grab that command. So I will look at the first topic and we'll list those out. Now again, keep in mind these are in Avro format, so they are binary, so they're not human readable. We could download one of these files from S3 and we can use the Avro tools jar to go ahead and read these. I won't do that for the sake of time. But you can see here that we are writing those raw sales transactions to the first Kafka topic. So we've listed the first 10 messages. And if we take a look at the second topic, and really I'm just confirming that there are in fact messages in these two topics. So we do see that messages are being written to the first one, and let's just confirm that messages are in fact being written to the second one. We can in fact see that they are, even though they're not human readable, kind of get the sense, and we do see the sales region here. So even though I can't read the rest of this, it's binary, and again we can decode that if we want to and actually look at the messages, but we're going to do that with our for script in a few minutes. Anyhow, I can see that there are messages being written to both the topics. I can see that in fact it looks like the region is being enriched with the sales data as they're being aggregated. So that looks good. We'll go ahead again and wait for both scripts to finish so we can see that our first script is still running. It should be coming to an end fairly soon, and we can see that our second script is in fact also still running. Again, the Spark Structured Streaming script is again Spark Structured Streaming, so it will not stop until I stop it. It will run continuously on the EMR cluster, consuming messages from that topic until such time that we choose to stop that. So I flip back to my first tab. This is the incremental sales script. This is the script that's been writing sales to Kafka. We can see that it finished. So it took about a half an hour to finish. It successfully wrote all 2,000 messages to the Kafka topic. If I flip back to the third script, which has been running, this is the one that is consuming the messages off of the Kafka topic. It's aggregating and enriching those sales and writing them back to the second Kafka topic. We can see that it has also paused because it's not finding any new data. And if I take a look, we can see batch 18. So we ran this, it generated about 18 batches. The first batch didn't contain any data. By the second batch, which was batch 1, because the batches started at 0, we started seeing messages consumed. And in fact, if we look at this, we see that we are now up to an offset of 2,000. So in the pagilla.sales.avro.demo Kafka topic, it has in fact consumed all 2,000 messages. It's aggregated those over, again, a 10-minute sliding window, an event time window with a 5-minute overlap, and it has written all that back to our two Kafka topics, which we just looked at. And although they're in binary format, we did confirm that both topics were in fact created and both topics contained messages. So that was a good sign. In the next part of our demonstration, we will be looking at the fourth and final script and using that script to look at the aggregated sales information, which the third script wrote after consuming and enriching the data. So the fourth and final PySpark script consumes messages from the second Kafka topic as a batch. The script then summarizes those final sales results, which have been aggregated and enriched with the sales region data by the Spark Structured Streaming script, and writes those out to the console by sales region. So we'll be able to see the results of our Spark Structured Streaming. I'm going to go ahead and run that in EMR. If I flip back over to my command line, I'm logged into the first cluster, the small cluster. That's where I'm going to run it. The Spark Structured Streaming job is still running on our larger cluster. You can see that, in fact, we're still at 2,000. Spark Structured Streaming will not continue to write micro batches if it doesn't find any additional messages. So it's waiting for additional messages. The last batch ID that it wrote was batch ID 18, or about 19 batches, micro batches, were written to Kafka. So I'm going to go ahead and run the fourth and final script. 13_batch_read_results_avro.py. So again, I'm logged into one of my two clusters, the cluster which is not still running the Spark Structured Streaming job, and I'll go ahead and run this job. The only reason I'm submitting these on the EMR master versus as an EMR step is I just want to take a look at the logs, and it's easier for the demonstration to see the logs as they're being created versus grabbing the logs once the job finishes in EMR. You could do either, and realistically you would probably be running these as EMR steps, but again, for the sake of the demonstration, we want to be able to take a look at the logs. So that's why I'm running these on the EMR master node versus submitting them as an EMR step, which normally would be the way that you would submit a Spark job. So we can see that this job has run. It only took about a minute to run. And we can see that we got back results. So again, if I look at the script, the end result is it shows 100 rows of data in our data frame. It prints that out to the console. So we read in the second Kafka topic. We then summarized those sales. So we did a batch read. We formatted the dates, the sales, made sure that all of our fields would print out correctly. And then we printed out the first 100 rows. So again, if we go back to the console, we can see that we have windows. So starting at 1525 or 325 to 1535 or 335. So we see a 10-minute window here. If we go down a little farther, we see another 10-minute window here. So from 320 to 330, again, and this continues. So you remember I said we had a 10-minute event time window that we were aggregating sales. So within this 10-minute window, what were the total sales results? So we have sales streaming in real time all over the globe. This real-time stream, what we're doing is looking at this real-time stream. We're aggregating the sales, and we want to know for each sales region, what were the total sales and total sales quantities within that 10-minute window. We have these 10-minute windows. We can see them continue to repeat for each one of our sales regions. If within a 10-minute window there were no sales to that sales region, we would in fact then not see it. So again, I've just printed out arbitrarily 100 rows, but we can see the end result of our Spark structured streaming job, which ran. It aggregated those sales by sales region and enriched the sales with the sales region, and then aggregated the total sales and the total number of orders. And it did that over the course of a 10-minute event time window. And we were able to read those back in with our fourth and final script and print those out to our console. Those were the 4 scripts that are part of the blog post. You can read a lot more in the blog post. There's much more detail. I have all of the commands listed. All of the code for this demonstration is open sourced and available on GitHub. Thank you.